Now let's take a look at another rule for differentiation called the product rule. So right underneath the power rule, you're going to write product rule, make a tab. And you might as well make a tab for the next one, which is called the quotient rule, make a tab, 2 lines across the margin and down. Alright, so take a look at the product rule. So what the product rule says is the derivative of two functions multiplied together is the derivative of the first times the second plus the derivative of the second plus the first. So two functions that are multiplied together is, this is a listening check, underline product rule in the title, underline product rule. 1. The derivative of the first function, in this case f, times the second function, not the derivative of it, just the second function as it is, times the second function. And then what we're going to do, we're going to add plus the derivative of the second function, so you see g prime, times the first function, just as it is, not the derivative of it, but just times the first function by itself. This is a listening check. Go ahead and box number 2. Box the number 2. So again, two functions multiplied together, derivative of the first function times the second function plus the derivative of the second function times the first function. So let's take a look at an example. Let's say we had this. Negative x cubed would be the first function and the parentheses would be the second function. So the derivative of the first function, negative 3x squared, times the second function just like it is, so the whole parentheses, plus the derivative of the second function, so looking at that, that's going to be multiplied together. 4 times 3 is 12x cubed, times the first function. The first function is negative x cubed. Alright, then I forgot to X off of that other step. Let's make step 3, simplify and combine like terms. Alright, so let's go ahead and simplify and combine like terms. So let's distribute negative 9, and then when you distribute the x, you add the exponents. That's what multiplying does. And the other one, negative 6x squared minus 12x, and again, when you multiply the powers, you're adding the powers. Alright, then we can combine like terms. That's going to give me negative 21x to the 6th power plus 6x squared. And that's it. Take a look at another example. So again, the first term is the first one. The second one is the second one. So derivative of the first function, negative 8x cubed times the second function just like it is, plus the derivative of the second function, which is negative 4x, times the regular first function, just as it is. Alright, let's distribute. You're going to get 16x to the 5th power, positive. Then negative 8x cubed. Plus, and I'm just going to leave this in parentheses so I can take care of the signs later and don't get confused. Negative 4x times negative 2x to the 4th power is 8x to the 5th power, and then positive 12x. And I'm going to get in with the positive, leaving everything the same, so I'm just going to write it all out. Combine like terms, so you're going to get 16 plus 8 is 24x to the 5th power, and nothing else can be combined, so everything else just comes down. One last example. Listening check. Put a triangle around example 3. Put a triangle around example 3. Square root of x times 3x. So again, square root of x is first term, 3x is the second term. Rewrite that square root in powers. So that's going to be x to the 1/2 times 3x. So first one is x to the 1/2, 3x is the second. Alright, so the derivative of the first, so that's going to be 1/2 x to the negative 1/2. Times the second, which is just 3x, plus the derivative of the second, which is just 3, times the first function, which is x to the 1/2. Alright, then let's clean this up a little bit. Let's put the x's on the bottom, so that's going to be 3x over 2 radical x plus 3 radical x. Let's make the denominator the same because we can have the radical on the bottom. So if I do it at the bottom, do it to the top. That simplifies to be 3x plus 6x, because a radical x times radical x is x. And then on the bottom, it's just going to be the common factor 2 radical x. Combine like terms, that's 9x over 2 radical x. Let's rationalize the denominator because you can't have it on the bottom, multiplying top and bottom by radical x. So that's going to give me on the top 9x radical x over 2x. And look at that, we can simplify the x's, so that leaves 9 radical x over 2. And that's pretty much it. So that's how you use the product rule. Let's practice.